So in this example, we are told that a painting sold for $256 in 1980 and was sold again in 1988 for $477. So we do need to determine the difference in time, subtracting 1988 minus 1980. So the time difference is 8 years later. Now we want to develop an exponential model. So we're going to start with the basic model. A of t equals a sub 0 e to the kt. And a of t represents the new amount. A sub 0 is your initial amount. And in the exponent, k is the rate of growth or decay, and t represents time. So in the information, my initial amount, which they call v sub 0, that's the same as a sub 0, is 256, and that's because that was the original amount that the painting was sold for. So I can update this equation by putting 256 in for the initial amount. Also, 8 years later, we have a new amount of 477. So I'm going to put 477 on the left side of the equation. In the exponent, we don't know k, but we do know the time is 8 years. So the exponent for e can be 8k. So in this equation, I have 477 equals 256 times e to the 8k. We're going to solve this equation for k. First, we need to isolate e to the 8k. So I'm going to divide both sides by the coefficient 256. So 477 divided by 256 is a decimal, and it's 1.86328,125. As you're solving these, it's a good idea to be very generous with how you round your decimals. Don't round to the 10th or the 100th because that can affect your precision. So I would suggest either writing the entire decimal or rounding to 5 or 6 places. So now we want to get rid of the e, and so the strategy for doing that is we take the natural log of both sides. So I have natural log of 1.86328,125 equals natural log of e to the 8k. Natural log of e cancels, those are inverses, and that allows you to pull down the power of 8k. So I have one more step as I finish rewriting what I have on the left side, and that's to get k alone, and I'm going to divide both sides by the number 8. So k, or the rate of growth, is going to be solved by doing natural log of 1.86328125 divided by 8. Notice that the MyMathLab program asks you to simplify this in the nearest thousands, so they do want 2 decimal places there. So go ahead and type in natural log and then that decimal that you have there, and then divided by 8. And the value that I'm getting is 0.0777923, and it keeps going. Since we want to round this to the nearest thousandth, I'm looking at 0.077. Look at the following digit, and if it's 5 or greater, we need to round the last number up. So the rate of growth is 0.078. Once you find that rate of growth, you need to update your model. So my model was coming back to the beginning, a of t equals a sub 0 e to the kt. In the context of this problem, they're using v for value instead. So the exponential function is going to be v of t equals, and we update the model with 2 numbers. The initial amount always is the same, so 256e, and the second thing is k is going to be updated with our rate, but the time you want to leave as a variable so that you can estimate the value in any number of years. So 256e to the 0.078t is going to be the function. So now that we have the function, we can make predictions. And in the next step, we want to estimate the value of the painting in the year 2007. So it's important when we want to evaluate the time that we go from the original time, 1980, to 2007 to get the years. So 2007 minus 1980 is 27 years later. So I'm going to use the function above and I'm going to plug in 27 for the time. So the value will be 256 times e to the 0.078 times 27. So if you have calculator questions on inputting this, let me know, because I would need to know the calculator model that you're using. But if you are able to get this input correctly, the answer is supposed to be 2103.12044, and then we check the rounding. So it says round this to the nearest dollar. So that would be looking at the decimal, which is a 1, and so we're going to round it at $2,103. Now, the last step asks about the doubling time for the value of the painting to the nearest tenth of a year. So the doubling time means how long does it take for the value to double from the original amount. So basically we're starting with $256 and then we want to double that. So 256 times 2 is $512. So we have our initial amount, V sub 0, and our new amount, V of t, 512. And we're solving for the time it takes to double. So the equation looks like this. The new amount goes on the left, 512 equals 256e to the 0.078 t. Since we're solving for this exponent, we do need to isolate the e again. So we're going to divide both sides by 256. And 512 divided by 256 is 2. So 2 equals e to the 0.078 t. To get rid of an e, we take the natural log of both sides. So natural log of 2 is natural log of e to the 0.078 t. Natural log of e cancels, and so we now have natural log of 2 equals 0.078 t. Our final step is to divide both sides by the 0.078 and then type that in the calculator. So t equals natural log of 2 divided by 0.078. So this gives me the decimal 8.8865 years later. And we want to round this to the nearest tenth. So it would be 8.9 years if we round to the nearest tenth.